Okie dokie, let's learn about fluorescence and phosphorescence. Fluorescence. Now, an atom is excited from one energy state to another by the absorption of a photon. We've talked about how to get atoms excited previously. Now, if this photon happens to be an ultraviolet photon, what can happen is if the electron can return to the ground state by making two or more jumps, one of these smaller jumps may be in the visible light range. And so this is what we're talking. So here's an ultraviolet photon. So let's say that the ground state's here, the excited state's there. That energy jump is in the ultraviolet range. So it's higher energy than visible light. And so that amount of energy is a big chunk of energy. Now the excited electron can jump back in two steps, for example here, and each of those steps will emit a photon. So these two photons will have the total energy of the ultraviolet photon, and one of these or both of these photons may be in the visible light spectrum. So from light that we can't see, atoms can then emit light that we can see, and that's what fluorescence is. And it's usually instantaneous, so the excitement state and then jumping back down happens very quickly. If there is a delay, so if the excited state exists for any period of time, we call that phosphorescence. And there's lots of occurrences of phosphorescence. So something like glow-in-the-dark signs are an example of phosphorescence, because after you get rid of like they absorb ultraviolet light during the day, or if a light is shone on them, and then once it gets dark or there's no more ultraviolets, they still emit photons, so you can still see them. Excuse me. But that's the basic concept of fluorescence. Pretty easy, pretty straightforward, and we'll have a look at a couple of examples in class as well. And I'll pull out something called fluorescein, which is a chemical that does this effect, has fluorescence. Now here, this is all saying much the same thing, just in words, so you can have a read of that. And in this case they're showing the absorption of the ultraviolet light, and the photons can, or the electrons can jump back in 3 steps, and each of these steps have to be at a lower frequency than the absorbed photon, and so one or more of these could be in the visible light spectrum. Some common examples of fluorescence are fluorescent minerals, and I'll show you a picture in a sec of fluorescent minerals, fluorescent tubes, and we'll talk about that shortly, fluorescent ink, the sort of highlighter ink that you use, glow-in-the-dark signs, anything that is absorbing ultraviolet light and giving off light. It's even put, fluorescent chemicals are even put into laundry detergent, and they're designed to actually coat your clothes and stay there after the whole washing process, because they're designed that when you put them out on a nice sunny day when there's lots of ultraviolets, those chemicals on the clothes will absorb those ultraviolet light and re-emit them as visible light, so your whites and your colours will look brighter than they normally do, and therefore you'll be convinced to buy that washing powder again. Not all of them do it, because some of the chemicals aren't particularly nice, and so it's just something to be aware of, that that's what they do. So when you bring in your washing from being all bright and colourful on the clothesline, and you bring it inside and where there's less ultraviolet light, they don't look as bright and as colourful. Now, how do household fluorescent lights work? This is particularly important because now we're replacing all the incandescent globes with fluorescent bulbs. So how do they work? Well, most of them are filled with a mixture of mercury and argon vapor, and basically they're a gas discharge tube filled with the mercury and argon vapor, but that would be a really harsh light if we just relied on those. And so what they have is they have a coating of a phosphor on the inside of the glass tube, and they're designed, specifically designed to absorb the ultraviolet light photons being emitted by the excited mercury and argon, and they re-emit them as visible light. And so when you turn off a fluorescent tube in complete darkness, you will then see that it glows for a little bit, and that's the phosphor coating. Now, the basic construction of them is pretty straightforward. You have 2 electrodes, and you have a high voltage going between the two. You have electrons whizzing across in a strong electric field, hitting the occasional argon or mercury vapor because they're introduced into the vacuum at a low pressure, and they emit your ultraviolet photons plus a small amount of visible light photons, and those ultraviolet lights then go onto the coating and get absorbed and cause the whole excited atoms and re-emission of visible light spectrum. So there's multiple stages happening. There's a thing called a starter, which basically just pumps it up and produces the current that's required in that case, and they all pretty much work the same. So that's why if you accidentally break open a fluorescent tube, you shouldn't breathe in the vapor. Plus there's also a white powder comes out, which isn't healthy for you either. But you shouldn't breathe in the vapor because there's mercury in, which is not good for you. Fluorescent minerals. Here's a photo of a whole lot of fluorescent minerals. Now basically these are being displayed in a cabinet with a light which is sometimes referred to as a black light. Basically it's a fluorescent tube that hasn't got the phosphor coating in it, and so it's just raining down photons in the ultraviolet range. It's what they used to use in tanning beds to tan you as well. And so these are all glowing, and you can see they're emitting visible light in lots of different colours, and some minerals are characteristic by the colours that they are given off. And the museum here in Launceston has had a good display, I think it still has, of fluorescent minerals, well worth popping in and having a look at. That's just a bigger one showing all the different colours, some of the agates and some of the carbonates, but also a lot of other minerals as well, most of which I wouldn't know the name of. Now in the next video, very short one, we'll look at Schrodinger's cat and what that has to do with us. See ya.